can all acquire an infection from pretty much any activity we do. And we know this to be especially true today, being in the middle of this COVID-19 pandemic. Infections can spread anywhere, such as the gym, the grocery store, or going to the hospital for a routine surgery. That's what happened to my dad. He came out having contracted a life-threatening infection from an antibiotic-resistant bacteria called MRSA. My dad survived, but others aren't that lucky. In the United States alone, there are 2.8 million illnesses and 35,000 deaths per year, which translates to one person dying every 15 minutes from a drug-resistant infection. This public health crisis is the motivation for my research. I work in the middle of a battlefield, not one created by countries at war, but between harmful bacteria and humans. In many ways, this struggle is like an arms race, where humans develop antibacterial products as weapons, but bacteria can evolve defenses, rendering those weapons ineffective. And when bacteria can defend against multiple weapons, they are called superbugs. Well, nanomaterials have emerged as an alternative tool to combat these superbugs. This technology aims to prevent infection rather than treat the disease once you are infected. I work specifically with silver nanoparticles, and one of their unique properties is an enhanced ability to interact with bacteria due to their really small size. And the cool thing about these nanodefenses is that we have a lot of control over them. We can change what they look like, their size, shape, and surface chemistry, and subsequently how they behave and interact with bacteria. However, emerging evidence both from the scientific community and my own work shows that bacteria can develop resistance to even these promising silver nanomaterials. And we're using this material everywhere. It's in clothing, cosmetic products, and in hospitals. So my research seeks to find out when this nanomaterial isn't working as well and why is that happening. And so I'm currently looking at the characteristics of the nanomaterial as well as the bacteria itself. Specifically, I believe that the way the bacteria move and how the nanoparticles aggregate or cluster together are important. And so if we can link these two characteristics together and understand how they interact, then we can design a more effective nanomaterial to overcome resistance and stop these superbugs. Benjamin Franklin once said, "An ounce of prevention is worth a pound of cure." Well, if my work is successful, we'll be able to ensure that this technology is effective when we need it most. For example, on surfaces in operating rooms, so that people, like my dad, won't continue to get life-threatening infections.